Hello everyone, my name is Komasinyolo. Welcome to another video by Attention Matrix, where we try to make learning fun and easy. Please comment, like, and subscribe if you would like us to continue making this content and you enjoy it or find it helpful. Now on to the next video. Let's get right into it. Just move this here. Okay, so we will be looking at the arithmetic number pattern and the arithmetic series in this lesson. Okay, so this is the first type of pattern that we will be looking at. The first type of number pattern that we'll be looking at. Okay, so let's say that you have an arithmetic sequence. Let's start with the simplest one. Let's say 2. Okay, you've got 2, 2, 2, 2, and 2. What makes this an arithmetic sequence? Okay, so the first number is called T1. This is the first number. The second number is called T2. The third number is called T3. And then the fourth number is called T4, and so on and so forth. Now, what makes this arithmetic? Why do we call it an arithmetic sequence? Well, we call it an arithmetic sequence because the difference, when you take the first term, and you subtract it from the second term, you get a certain answer that we call a difference. Okay, when you subtract the 2, you get a difference. And when you take the third term and you subtract the second term, you get another difference. And when you take the fourth term and you subtract the third term, you get another difference. Now, all these differences are the same. Okay, so for an arithmetic sequence, all these differences between these numbers are the same. So in this instance, T2, okay, T2 is equal to 2, and T1 is equal to 2, and T3 is equal to 2, and T4 is equal to 2, and T5 is equal to 2. Now, in this case, note that all the terms are equal, but T5 minus T4, for instance, let me just do this. T5 minus T4. What is T5 minus T4? T5 minus T4 is equal to 2 minus 2, and that gives you 0, and 0 is what we call D, the common difference. Okay, what is T3 minus T2? Remember, it has to be the term minus the term before it. Okay, so T3, if we go up there, how do I scroll up? If you scroll up here, you will see that T3 is equal to 2, and T2 is equal to 2. Okay, so all of these terms are 2's. That's just what I wanted to show you. So T3, in this instance, that is 0, and that is 0. Sorry, that is T3 is 2, and T2 is 2 also. So T3 is 2, T2 is 2. Therefore, 2 minus 2 is equal to 0, and this is also D. So the D's are the same. The difference between two successive or two consecutive terms are the same, and that's what makes this an arithmetic series. Okay, so now let's look at a second type of a different pattern or a different sequence. Okay, let me just remove all of this so that we can look at a second or a different pattern. Okay, so let's look at a different pattern. Now let's look at another simple pattern. Let's say I've got 1, okay, I've got 2, I've got 3. This is a pattern. I got 4, I got 5. It's a sequence, and I've got 6. Okay, so a sequence of this nature also has a common difference, or a common d, or a d that doesn't change, a d that stays the same. Because why? Notice that this first term here, this is t1, okay? This is t1, and this is t2, this is t3, this is t4, and so on and so forth. This is t5, and this is t6. Now, what happens when I start subtracting things and I start taking differences between the terms, between successive terms, terms that follow each other, okay, consecutive terms? Well, this is what happens. If I say t2 minus t1, what is my answer? My answer is, oh, well, this is going to be, I'm going to substitute first before I get to the answer. T2 is 2, right? Because that's the second term. T1 is 1. And the difference is 1, because 2 minus 1 is 1. And that is what we call D. Okay, what happens if I say T3 minus T2? If I say T3 minus T2, then what I get is T3 is 3. And then T2 is 2. And 3 minus 2 is 1, and this is equal to D. Okay, and these two answers here are the same, because both of them are 1. Now, this is going to happen between any two successive numbers. Any two successive numbers that you look at, whether it's T4 and T3 or T5 and T4, that's going to happen. Now, what's not going to happen is you're not going to get a common difference if you look at two terms that are not successive. If you get two terms that don't follow one another, then you're not going to get a constant difference. Okay, so for instance, if you look at T6, that's 6, right? If you look at T6, just do this. If you look at T6 and you look at T4, what is T6 minus T4? I'm looking at these two here. T6 minus T4, right? So T6 minus T4 is equal to 6 minus 4. And that's going to give you 2. Now, this is not equal to D. This does not mean that this is not an arithmetic sequence. It is an arithmetic sequence. The rules say that you have to subtract two successive terms, or two terms that follow one another. They have to be next to one another. You can't skip a 5, just like we did here. You can't skip this term here. You can't skip this term here and focus on this term and that term here, because then it's not going to give you a constant difference when you're checking if this is an arithmetic sequence or not. Okay, so that's what makes this an arithmetic sequence. Now, there is a rule, or there is a formula that describes the sequence. Okay, there is a rule. So instead of having to calculate each term individually, there's a rule that you can use to find out the position of the term and the value of the term. Now, before I actually show you the formula, I just want to give you more clarity on what I mean. So I'm just going to use the same sequence. Let's say 1, you've got 1, you've got 2, you've got 3, you've got 4, and so on and so forth. Now, if I asked you, this is term 1, right? This is term 1. 1 is term 1. 2 is term 2. 3 is term 3. 4 is term 4. And 5 is term 5. If I asked you what the next term is here, you're going to tell me that it's 6. I'll ask you for the next one, you're going to tell me that it's 7. I'll ask you for the next one, you're going to tell me that it's 8, and so on and so forth. Now, the way you would have gotten to the 6 or to the 7 is that you would have just taken the last term there that you saw, and added the common difference, which is D. You would have added D to get to the next term of 6. Now, D in this instance is 1. So all you do is you add 1 to a number to get to the next number. Okay, so easy, right? Now, let's say you had, let's make it a little bit more complicated. Let's complicate it just a little more, this sequence. Let's say you had this sequence. You had 1, then you had 3, then you had 5, then you had 7, then you had 9, then you had all these other numbers going on ahead. Now, what would you do to determine the number that follows 9? Well, you would simply find the common difference. Remember, how do you find the common difference? Well, you look at any two successive terms that you've been given, right? And then you find the common difference. So this is 3 minus 1, because T1 is 1 and T2 is 3. Okay, this is T3, this is T4, and so on and so forth. So now what you would do to determine the term that follows 9 is that you would find the common difference. What is the common difference? Well, the common difference is the difference between any two successive numbers or any two successive terms that follow one another. So I'm just going to choose randomly. I'm just going to take the difference between. I'm just going to take the difference between. Let me just move this up there. I'm going to take the difference between T2 and T3, T3 and T2, right? The difference between T3 and T2. What is T3? T3 is 5 and T2 is 3. So T3 is 5, T3 is 5, and T2 is 3. So the difference between the two, T3 minus T2 is equal to 5 minus 3, and that's going to give you 2. Okay, so then the common difference in this case is 2. D is 2. So what you would do to get the next term up here is you would simply add 2 to 9 and keep adding 2 to get more terms. Okay, you'd keep adding 2. So 9 plus 2, 9. If you add 9 and 2, what do you get? You get 11. If you add 11 and 2, what do you get? You get 13, and so on and so forth. So now you can calculate the next terms. Now this is a long procedure. Or what if they asked you? What if they asked you to calculate T? Let's say they asked you to calculate T100, right? This means that they want you to find the 100th term. Now, you're not going to keep adding 2. You're not going to keep adding this 2 up until you get to term 100. I mean, you can do that. You can do that. Nothing is stopping you from doing that. And you will get to the right answer, and you will get all your marks, actually, if they haven't asked you to use the formula specifically, because it's just a procedure that you're choosing to follow and it's correct, right? But that's going to just take too long. What if then they asked you to find term 1 million, the 1 million or the millionth term? You can't keep adding 2. You're gonna keep adding 2, thousands of times before you get to term 1 million. Now there is a formula. Back to what I was saying earlier on. There is a formula that you can use to determine the value of any term in any position of the sequence. Okay, there is a formula that you can use to determine the value of any term in any position of the sequence, and that's the formula that we are going to look at right now. Okay, so what is that formula? Well, that formula is as follows. That formula is as follows. You got Tn, okay? You got Tn, where n is the position of the term. Tn. Remember, I had T1, I had T1, I had T2, I had T3, and I had T, all of those things. This is what n is. Okay, just shows you the position. So Tn, okay, the position of the term and the value of the term is as follows. Tn is equal to A plus open bracket n minus 1 times d. Okay, so this is the formula, right? This is the formula that you can use to determine the value and the position of the number that they're asking you to find. They ask you to find the millionth term. What you do is you whip out this formula and you just get to solving. Now I'm going to explain this formula. I'm going to explain how to use this formula to actually do the solving. It's quite simple. It's not difficult at all. Just you need to know this formula. It's going to be provided in the formula sheet if you don't memorize it, so that's fine. I want to explain what each term in this formula means. Okay, so just gonna increase this slightly to 4. Okay, so this here, A, represents the first term. Okay, the first term in your sequence. The first term in your sequence. That's what A stands for. First term in your sequence. That's what A stands for. Okay. D, I described it earlier on, is the constant difference. Meaning, when you take two successive terms and you subtract them from one another, that's the value that you're going to get. The constant difference. It has to be constant. It has to be constant. Okay, it's a constant difference. So, and then N is the position. So remember, if you had T1 or T2 or T3 or T4, whatever, this represents the position. I'm just going to rewrite this formula nicely so that I have more space. Then I'm going to describe it further. So let's write it out again. You've got T n is equal to the first term, which we call A, plus open bracket n minus 1 close bracket times d. Okay, so remember this represents your first term of the sequence. First term. This represents your position of your term. Position of your term. So if this is 5, it means you're looking at T5. If this is 7, it means you're looking at T7. These two values are always going to be the same. Let me just show you which two values are going to be the same. This value and that value, both of them are n. So both of them have to be the same. This just means that whatever value you see here is the value that you put in here, that you use in your calculations. Okay, the fact that it's a subscript doesn't mean anything really. You might as well have it like this, the way you write functions, you know, the way you write functions. You know that when you write functions, the value inside the bracket is the value that you're going to use in the formula. Okay, so it means exactly the same thing. The fact that it's the factor that is at the bottom there means nothing really. Okay, and then this is the constant difference. Okay, this is the constant difference. Constant difference. Now, what does this mean? Let's show you what it means. Let's go up. I'm going to use the sequence that I was using earlier on before. The two sequences, actually, I'm going to use them both. So I'm going to start with the first one. Now, how do you determine if something is an arithmetic sequence? Remember, the difference has to be constant. Remember, the first sequence that I started off with was this one, right? 2, 2, 2, 2, 2, right? And I said, what tells you if something is an arithmetic sequence? Well, if you take two successive terms and you subtract them, and you do that over and over again at different points of the sequence, you get a constant difference that we call D. Doesn't matter if the constant difference is 0, just like it is here. 2 minus 2 is 0. 2 minus 2 is 0. So the constant difference here is 0. All of them here are 0. Therefore, this is an arithmetic sequence. Okay, now I tell you, I ask you, I say, determine the value of, I ask you to determine the value of T76. Okay, T76. In other words, what am I saying to you? I'm saying, give me the value of the number on position 76 or in position 76 of the sequence, right? Give me the value of the number in position 76 of the sequence. Now, in this instance, we can get to the answer immediately because all the terms in the sequence are 2. The first term is 2, the second term is 2, the third term is 2, the 10th term is 2, the 20th term is 2. So term 76 is also going to be 2. Term 76 is also going to be 2. But how do we prove that using the formula that I showed you earlier on? Well, this is how you would prove it. Okay, so you've got t. Remember the formula says Tn is equal to A plus open bracket n minus 1 times d, right? We know that for the sequence that we are looking at, our d is 0. How do we know that our d is 0? Let me just erase this line that I put in here. How do we know that our d is 0? Well, when we take any two successive terms, when we take any two terms that follow one another and we subtract them from each other, we get 0. Therefore, d is 0. That's how we know that our d is 0. Now, what is our a? What is our a? Our a is, if you look at the sequence up here, a is 2 because a is simply the first term, right? A is the first term. So where is the first term in the sequence? Here's the first term. It's term number 1. It's the term in the first position of the sequence. So this is what a is. Okay, a is this term. That's what a is. That's all that a is. It's nothing complicated than that. Okay, so a is 2 and d is 0. So if we just start substituting things here, what are we looking for? We're looking for T76. Remember what I said? I said T76, this subscript here, this subscript here tells you, let me just circle it and stop calling things by name. The subscript here, this is what I mean by subscript. The subscript here simply tells you what to substitute for n in that equation. Okay, so that's all you're going to do. You're going to take the subscript and substitute it in place, and substitute n, and then you're going to do your math, do the calculations. So what you are going to see here then is that we get t, instead of n, we're going to write 76 is equal to a. Remember what we said? We said a is the first term, and the first term is 2. Okay, so instead of writing in a, we are going to put in 2 plus open bracket n is 76 minus 1 times what? Times our common difference. Our common difference is d. And then we can solve. What do we get when we solve? We've got 2 plus, what is 76 minus 1? It's 75 multiplied by 0. Now, anything multiplied by 0 is 0. So that falls away because that becomes 0. And then we get 2 plus 0. So T76 is 0. The 2 plus 0 is 2, right? 2 plus 0 is equal to 2. And this is our answer. So we know that T76 is equal to 2. T76 is equal to 2. Let me just write it nicely. T76, which is what we were looking for, is equal to 2. Not equal to 0. It's equal to 2. It's equal to 2, and then that's our answer, and then we've solved. So we know that in the 76th position of the sequence, we are going to get an answer of 2, and we know that this is true because we know that for all the positions we're going to have 2. For all the positions you're going to have 2, and we've just proved it mathematically. Okay, that's how you use this equation. It's simply, you just have to know which variable stands for what and substitute it in. Okay, we are going to solve a bunch of questions in a separate video. We're going to go through past exam papers. We're going to cover all these things on a separate video. So this is just an introductory video with the most basic concepts explained. The second sequence that we looked at, 1, 2, 3, 4, 5, 6, 7. Etc., 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 and so on and so forth. Remember what we said earlier on is that how do you know if this is an arithmetic sequence? You know that this is an arithmetic sequence if the difference between two successive terms, which we call the constant difference or the common difference, and we use d to refer to it. If the difference between two successive terms is the same at all instances of the sequence, then this is an arithmetic sequence. Now, what is the constant difference between two successive terms here? We calculated it earlier on, right? 2 minus 1 is 1. 3 minus 2 is 1. It's just the difference between all the successive things. So 3 minus 2 is 1. 4 minus 3 is 1. 5 minus 4 is 1. 6 minus 5 is 1. This is common. You're always going to get 1. Regardless of which successive terms you subtract from one another, you're going to get 1. Okay, so now how do we use the formula? Now let's try to calculate T76 for this one. What if they ask you, what is T76? You know that in this case, T76 is going to be, you just keep adding 1 up until you get to T76. But you don't want to do that because that's a long approach, right? What is T76? Using the formula. Well, using the formula, you have Tn is equal to A plus n minus 1 times d. Remember what all of these terms stand for. A is the first term, d is the common difference. Okay, and n is that value there, T76. They ask you, what is T76? Dear student, tell us what T76 is. You just take the first term. The first term, we remember from up here, the first term is 1. You can see that term number 1 is 1 in this sequence here. So you take this and you say that's 1 plus, what is n? N is 76 minus 1, then times the common difference, which is 1. We calculated it, that's 1. And then you just simply solve, right? That's 1 plus 76 minus 1 is 75. Okay, times 1. Okay, then you've got 1 plus 75 times 1 is 75. So term 76 is equal to 76. T76 is equal to 76. How do we know that this is true? How do we get more comfort? How do we get more comfort that this is true? Well, you look at your sequence here. You look at the value of T1. I want to show you something. Look at T1. T1 is this value here. This is T1, right? T1 is equal to 1. T2 is equal to 2. T3 is equal to 3. T4 is equal to 4. T5 is equal to 5. T6 is equal to 6. T7 is equal to 7. So you can see that when n is a certain value, the value of the term number is also that value. T4 is equal to 4. T5 is equal to 5. So, you can infer by logic, you can infer or you can deduce, or you can come to the conclusion that T76 is going to be equal to 76. Okay, which is what we got down here. We just proved that mathematically down here. T76 is equal to 76 because the equation that we used here, we used correctly, gave us the answer that T76 is equal to 76. Okay, and those are the basics, those are the fundamentals of what an arithmetic sequence is. We will look at what an arithmetic series is in the next video. Okay, but as far as arithmetic sequences go, this is the formula up here that you need to know and to understand and to know how to use, and when. Most importantly, you need to know when to use it. You use it for arithmetic sequences only. You don't use this formula for any other kind of sequence. Okay, so if they give you any other kind of sequence and the difference between two successive terms is not common or is not constant, then you do not use this formula. You only use this formula if the difference is common. Okay, so that is what those are the fundamentals of what an arithmetic sequence is. Till next time. Lesson number 1.